So today we're going to divide fractions, learn how to divide fractions. First of all, what is half of 8? Draw a picture to show this situation. Go ahead and do that. So I have 8 things. I'm going to find half of it by putting a line right down the middle. Now I can see that I have 4 things. So half of 8 is 4. All right. Now I'm going to multiply 8 times 1/2. And to do that, I'm going to write 8 over 1, multiply that times 1 over 2. Remember that I can reduce before I multiply across, so 2 goes into 8 4 times, goes into 2 once, and now I multiply across, I get 4. I got, again, half of 8 is 4, 8 times 1/2 is also 4. All right, now I'm going to do 8 divided by 2. Draw a picture to show this situation. Now, I could actually use the same picture. I have 8 things here, and I've divided them into 2 groups. So that's really the same thing as finding half of 8. So 8 divided by 2, I can do the same idea with a picture, and I could use the same picture or draw another one, but it's basically the same thing. Okay, so is there any difference between multiplying by 1/2 and dividing by 2? Well, we could say that there are, in terms of the names of that, we can say there are, but really they are the same thing. Multiplying by 1/2 or finding half of something is the same idea as taking something and dividing it by 2. So is there any difference? We could say semantically there is, but technically with math, there's not. What about dividing by 1/2? How does that compare to multiplying by 2? If these two are basically the same in number 4, then in number 5, are these the same, dividing by 1/2 and multiplying by 1/2, and multiplying by 2? So to show an answer to this one, I started off with the number 4. I said, well, let's take 4 and divide it by 1/2, and let's take 4 and multiply it by 2 and see if we end up with the same thing. So dividing by a fraction conceptually is very difficult for people. So 4 divided by 1/2 is the one that I want to be able to show. We know, you guys know that 4 times 2 is 8, but the 4 divided by 1/2. So I've drawn 4 circles here. Now I'm going to divide that in half, which means basically what I'm asking is how many 1/2s fit into 4? Well, I need to basically divide these into halves. So I'm going to basically cut each one of these in half. Now I have, so how many halves? Well, here's 1, here's 2, here's 3, here's 4, here's 5, here's 6, here's 7, here's 8 halves fit into 4. So 4 divided by 1/2, which is asking how many halves fit into 4, the answer is actually 8. And 4 times 2, the answer is also 8 in there. So how would half compare to dividing by 2? It is the same thing again. All right, so we're going to move on to dividing by fractions here and show why multiplying by the reciprocal works. So we're going to take a fraction divided by a fraction could be written just like this, where I have a fraction over a fraction like this being division. And what makes this challenging, I'm sure you would agree, having that 4/5 in the denominator makes this really uncomfortable and really ugly. So our idea is that we want to get rid of that 4/5. And we learned in the last unit that when you multiply something by its reciprocal, so for instance, the 4/5 in the denominator, if we were to multiply that by the 5/4, the 5s and the 5s cancel out, the 4s and the 4s cancel out, and that's going to end up over here as a 1. Those multiply. That's the thing about that multiplicative inverse, also called the reciprocal. But remember that we can't just multiply that denominator by that. We have to, in order to keep the fraction the same without changing its value, we have to multiply the top by the same thing. So we have 2/3 times 5/4 in here, and we can reduce this, the 2 and the 4. 2 goes into 2 once, 2 goes into 4 twice, and now we can multiply across and we'll end up with 5 halves. All right, so we have basically 5 halves divided by 1, which is simply 5 halves, or 2 and 1/2 when we get to the end there. Now, so you can do this each time, is simply multiply the denominator by the reciprocal there, or realizing that we're basically just multiplying the numerator by the reciprocal, we can learn sort of a trick, which is basically whenever you're dividing, you're going to do 2/3 instead of dividing by 4/5, you're going to change division to multiplication and multiply it by 5/4. Again, the reason why you can change division into multiplication is because that's what we're doing. When we look back here, in order to get rid of that 4/5, you multiplied by the reciprocal, both the numerator and the denominator, and because it cancels out in the denominator, we can kind of ignore that part every single time and realize it's always going to end up at 1 in the bottom, and we can just change the division into multiplication by, over here, we realize we're simply going to take that 2/3 and multiply by that 5/4 and be able to get our answer there. And so our answer here is 2.5. So let's go ahead and try it with number 7 as well. I'm going to do this both ways. So let's do it the long way and say, all right, we've got -3/8, and we are going to divide it by 9/4. Again, we can multiply by to get rid of the denominator, we're going to multiply it by its reciprocal, and that's going to turn out to be 1. And then I'm going to take the -3/8 and multiply it by 4/9. We're going to be able to reduce, let's see, 4 goes into 4 once, goes into 8 twice, 3 goes into 3 once, goes into 9 3 times, and it's a -1 over, and this was 2 times 3, which is 6, so we get -1/6 there divided by 1, which is -1/6, okay? A neater way to do it is to write it without the fraction, without the denominator. We can basically just take the fraction, and instead of division, we're going to change it into multiplication of the reciprocal. And we do the same work that we did before. We've got 2, 1, we've got 1, 3, and we multiply across, and we've got -1/6. Okay, so this one's a shorter version that I just did there without having to put in the denominator there at all. We simply have to take a division of a fraction is the same thing as the multiplication of its reciprocal. And this is basically here the reason why that works. But we can simply take that shortcut every time if we want. Let's go ahead and try number 8. We have 2/3 divided by 3. Well, that really means 2/3 divided by 3/1. Instead of multiplying by 3/1, we can divide, or sorry, instead of dividing by the 3/1, we are going to multiply by its reciprocal and multiply across. We get 2 over 3 times 3, which is 9, 2/9. Okay, so we can look at how that algorithm worked. We could keep practicing that. But hopefully you've already seen the Edpuzzle, understanding sort of a visual idea of what division is. And we're going to do a few examples of that, of drawing. So we're going to draw a picture to show how many 1/8 can fit into 3/8. So find some way of drawing a model of 3/8 and then basically figure out how many 1/8 can fit into those. So I've drawn a picture of basically a fraction bar here, and I have there's 8 pieces, and I've shaded in 3 out of 8. So this is my 3/8. So how many 1/8 can fit into 3/8? Well, here's 1, here's 2, and here's 3. So we have how many 1/8 can fit into 3/8? Well, 1, 2, 3 of them. So the answer is actually, how many 1/8 can fit into 3/8? The answer is 3. What's the best way to interpret 3/8 divided by 1/8? That's exactly what we just did. What we did up here is the best way to interpret it. We are finding how many 1/8 can fit into 3/8. All right? And so the answer of that's 3. Just to check, let's check our algorithm. Remember what we did? We did 3/8, and instead of dividing by 1/8, we multiply by its reciprocal, which is 8/1. We can cancel out 8 goes into 8 goes into 8 one time, and we multiply across, and we get 3/1, which is 3. Same answer where we got it looking at the concept visually. We can use that quick algorithm by simply multiplying by the reciprocal to see that it works and that it really means the same thing that we're doing. So I want you to try 9C now. See if you can, again, draw a picture. We can use the same kind of picture here and see how many 2/8 can fit inside of it. So once again, I have my model here, a picture of 3/8, and I want to know how many 2/8. Well, okay, so here is the 3 yellow ones are my 3/8. How many 2/8? Well, here is 1 2/8 that can fit in there. All right, and then how many more 2/8 can fit? Well, I don't have a whole 2/8. I have another half of a 2/8. So I can fit one. Let me say my microphone just got muted there. I have 1 2/8 and 1.5 2/8. So that's 1.5 2/8 that I can fit in there. The answer is going to be 1.5. All right, let's go ahead and try to draw a picture again of our 3/8. And we're going to this time try to divide it into 3/4 and see how that goes. So I have my fraction bar here showing 3 out of 8 of them are filled in, and I'm going to try to figure out how many 3/4 can fit in there. Well, 3/4 is the same thing as 6/8. So if I multiply by 2, I get 6/8. So how many 6/8? Well, I can't fit a whole 6/8 into 3/8. But if I look at it here, I would have, in this case here are 6/8. How many of these green ones can fit into the yellow one? Well, only half of that green one can fit in there. So I'm actually can only fit half of a 6/8 into a 3/8 right here. So that's half of a 6/8. So the answer is actually going to be 1/2. Let's go ahead and try the algorithm where we can do 3/8, and instead of dividing by 3/4, we're going to multiply it by 4/3. We can 3 goes into 3 1, 3 goes into 3 one time, 4 goes into 4 one time, goes into 8 two times, and we multiply across and we get 1/2. Sure enough, our algorithm matches our conceptual understanding of what it means to divide 3/8 divided by 3/4. Let's try the same thing, this time using a common denominator. So using the common denominator here, we're dividing 3/8 divided by 3/4. So I'm going to write 3/8, but instead of writing divided by 3/4, I'm going to write divided by, we're going to get a common denominator. So 3/4 can be changed into 6/8 like we found over here. So we're going to do 3/8 divided by 6/8. So this is another algorithm, another way of doing division here. And we can divide across here. We're going to do 3 divided by 6. 3 divided by 6 is 1/2. And 8 divided by 8 is 1. So it's going to be 1/2 over 1, which is 1/2. This is another way, another algorithm. So you can, if that's easier for you to get a common denominator when you're doing fractions, then you can simply ignore the denominator here. This part if you get a common denominator when you divide, those will always divide out to be 1 in the denominator, which basically you don't need to do. And then you simply do 3 divided by 6 is 3/6 or 1/2. And that's going to give us our answer there. So we get the same answer here, same answer here, same answer here, whether we're using the visual model, if we're multiplying by the reciprocal, or if we do it using a common denominator. So we're going to end this video right now, but you're going to need to go on and watch the next videos for the next part.